All right, let's get into it. There's this new research paper that's making some serious waves, and it basically says, what if the AIs we've already built are way smarter than we realize?
I mean, think about it. For years, the name of the game has been train, train, train. More data, more compute, just relentless coaching to make AI smarter. But what if that's not the whole story? What if the genius was already in there, and we've just been trying to teach it things it already knows? This paper asked that exact question, and let me tell you, the answer? It could genuinely change everything.
Okay, so to really get why this is such a bombshell, we've got to quickly cover the status quo. How do we build these super powerful AI reasoners right now? Well, you can think of it like an AI training treadmill. So the main way we do this is with something called reinforcement learning, or just RL. You take your base AI model and you put it through this brutal post-training boot camp. It's kind of like training a dog, but for math problems. You give it a problem, say a complex equation. If it gets it right, boom, it gets a digital treat, a reward. Gets it wrong, no treat. You do this over and over and over, literally millions of times, and what you end up with is a highly specialized, really powerful reasoning machine.
But here's the catch. This whole approach, this relentless focus on drilling for that one single correct answer, it comes with some pretty serious baggage. There's a hidden cost to this AI training treadmill, and it's a big one.
First off, the obvious stuff. The practical costs are just insane. We're talking massive, expensive supercomputers running for weeks. You need these gigantic, specially curated data sets, which are a nightmare to create. And here's a big one, you need a verifier. That's something that can instantly tell the AI if its answer is right or wrong to give it that reward. For a math problem, maybe that's easy. But for a complex, real-world question, yeah, not so much.
But okay, beyond the cost, there's a much more subtle problem. And this quote from the paper nails it. What happens is that RL basically trains the creativity right out of the model. It gets really, really good at giving you one specific kind of correct answer, but it forgets how to think outside the box. It becomes, for lack of a better term, a one-trick pony.
And this right here is the perfect picture of what's happening. Look at the model trained with RL. See how all the answers are clustered around that single peak? It's hyper-focused, sure, but it's also incredibly narrow. It found one good way to answer, and now that's all it does. This is what researchers called mode collapse. The model basically collapses all its creativity into one single mode. It's lost its range.
Okay, so this is where the paper just flips the script entirely. It asks a really radical question. What if all this expensive, time-consuming retraining isn't actually creating new skills? What if it's just sharpening an ability the AI already had?
And that's the central mystery they set out to solve, right? Are these amazing reasoning skills we see after RL? Are they brand new abilities that we've hammered into the model? Or are we just uncovering something that was lying dormant in the base model all along?
This is the big idea, the paradigm shift. The paper's hypothesis is that reasoning isn't a feature you have to add to an AI. It's an ability that's already there. You just have to unlock it. The problem isn't that the base AI is dumb, it's that our methods for getting answers out of it are.
So you're probably wondering, okay, if there's a lock, what's the key? Well, the researchers came up with this incredibly clever and, get this, training-free technique to do it. It's called power sampling.
So to get what makes power sampling special, you have to compare it to the standard way of doing things. Most methods are, well, greedy. They just look for the single best next word to generate. It's like a chess player who only thinks one move ahead. You can easily walk into a trap. Power sampling is totally different. It's strategic. It's like a grandmaster. It doesn't just look at the next word. It evaluates the entire path, the whole sequence of words, to see which one is most likely to lead to a great answer. It's literally planning ahead.
And the process itself is so elegant, it's beautiful. Think of it like how you'd write something. First, the AI just drafts an initial rough answer, step 1. Then it goes back and proposes a change, a revision, step 2. Now here's the magic. Step 3, the base model, with no outside help, looks at that revision and asks itself, is this new version a more promising path to a good answer? And finally, step 4, it decides. If yes, it keeps the change. If no, it scraps it. And then it just repeats, draft, revise, check, decide. It's constantly improving its own answer.
So the big question is, does this all actually work? I mean, it sounds cool in theory, but how does this simple, training-free underdog method stack up against the heavyweight champion, reinforcement learning? Well, the results are nothing short of stunning.
Just look at this chart. This is a tough math benchmark. The first bar, that's the base model on its own. It doesn't do great. The middle bar, That's the model after all that expensive RL training. Huge improvement, right? But then look at the last bar. That's power sampling. With zero, and I mean zero, additional training, it gets right up there with the heavily trained model. It's incredible. But it actually gets even crazier. So on the math problems it was trained on, the RL model is a little better, fine. But what happens when you throw them a curveball? What about tasks they weren't specifically trained on, what we call out-of-domain stuff, like coding or answering general questions? Well, look at the table. Power sampling doesn't just compete, it flat out beats the RL model. It's more flexible, more adaptable, it's a better generalist.
And just to really hammer this home, for one of the models they tested, this simple sampling technique boosted its coding performance by over 50%, 51.9%. Let that sink in for a second. That's a massive leap in capability, and it cost absolutely nothing in terms of extra training.
And hey, remember that whole mode collapse problem? That creativity issue? Well, power sampling fixes that too. This quote from the paper basically says that when you ask the model for several different answers, power sampling crushes it. The RL model just gives you the same thing over and over, but power sampling gives you a bunch of different high-quality options. You get the accuracy and the diversity. It's the best of both worlds. So okay, what's the big takeaway here? Why does this matter so much? Because this isn't just some neat new trick. This could point to a whole new direction for how we build and use AI.
I mean, just look at the advantages. It's training free, you don't need a special data set, you don't need that verifier we talked about. All of that means it's way more efficient and way more accessible to everyone, not just the giant tech companies with billion-dollar compute budgets.
And this really gets at a fundamental shift in philosophy. For the longest time, the mantra has been more compute at training time. Just build a bigger, more expensive model up front. This paper suggests a different path. Use more compute at inference time. That means when you actually ask the AI a question, it spends a little more time thinking about the best answer. Instead of just building a smart AI, you're helping it act smarter in the moment.
And the authors themselves really say it best. Basically, the base models we already have are way, way more capable than we've been giving them credit for. The problem wasn't the models, it was how we were talking to them.
And that just leaves you wondering, right? If this incredible reasoning ability was just sitting there hiding in plain sight the whole time, what else is in there? What other amazing skills are lying dormant inside these AIs, just waiting for someone to find the right key to unlock them?